First things first, I want to smush these so that they have a common denominator. So my common denominator is going to be that x minus 1 times the x. And this guy, to make that common denominator, he's missing the x. And this guy is missing the x minus 1. So now that I've gotten a common denominator of x times x minus 1, x times x minus 1, I can go ahead and subtract my numerator. So I'll have 3x minus 4x minus 1, and be super, super careful to distribute that negative. So it's 3x minus 4x plus 4 over x times x minus 1 greater than or equal to 0. So that'll be minus x plus 4 over x times x minus 1 greater than or equal to 0. Excellent. So now that I have it in this gorgeous factored form, I can tell exactly where it equals 0. So it'll equal 0 when x is 4. And I'll take that. When it equals 0, I want it to be greater than or equal to 0, so I'll put a nice solid dot there. And I also want to put where it's undefined, which is where the bottom is 0. So at 0 and at negative 1, it's undefined. And no matter what that greater than or equal to, I don't want to be undefined. I'm going to put open dots there and there. Not allowed to equal 0, and I'm not allowed to equal negative 1. Okay, now we test. Any number bigger than 4, a billion. Negative a billion plus 4 is going to be negative. A billion times a billion is positive. A negative divided by a positive is a negative. So I actually start out negative over there. But because these are all to odd multiplicities, they're all to the first power, I can safely alternate my signs. So negative, positive, negative, positive. And I'm going to be, I want the greater than or equal to 0, so I want the positive. So I want anything between here and here. So I'll take any x's starting with negative infinity, going to negative 1, not including negative 1, uniting that with x's starting at 0 but not including, and going to 4 including. And that's my answer. Yay!